Here we have an initial value problem, 2y double prime plus y prime minus y equals x plus 1. Initial conditions are y of 0 equals 1 and y prime of 0 is equal to 0. We could totally solve this using undetermined coefficients as in the previous set of videos, but we're going to do this using variation of parameters. And the first step is going to be solving the auxiliary equation, 2m squared plus m minus 1 is equal to 0. That factors into, when you're factoring something as basic as this, please double check that you got everything correct. This is going to be 2m minus 1 times m plus 1. And so we have that m is equal to 1/2 or negative 1. Our complementary function then is y sub c is equal to c1 e to the 1/2 x plus c2 e to the negative x. Now before we form really w1 and w2 for variation of parameters, we need to put the equation into standard form. So we've got y double prime plus 1/2 y prime minus 1/2 y is equal to 1/2 x plus 1/2. That standard form doesn't matter for w because w just comes from y1 and y2. It does matter for w1 and w2 because we're replacing the columns with 0 and then f of x. So this, in this case, is our f of x. Using the information that we have now, I'd like you to form w, w1, and w2, and in fact, take this problem as far as you can, and then come back, and I'll start doing some work on it. I haven't finished it all yet, but I wanted to make sure we were on the same page. I have that w is the 2 by 2 determinant with the first row e to the x over 2, e to the negative x. The second row is 1/2 e to the x over 2, negative e to the negative x. Computing that determinant and simplifying, collecting the like terms gives us negative 3/2 e to the negative x over 2. w1 is the same as w, except the first column is 0 and then 1/2 x plus 1/2. And when we compute that determinant, we get negative of 1/2 x plus 1/2 times e to the negative x. Likewise for w2, we have e to the x over 2 times 1/2 x plus 1/2. w1 over w, once everything is simplified, turns out to be 1/3 x plus 1 times e to the negative x over 2. w2 over w is negative 1/3 quantity of x plus 1 times e to the x. If you didn't have this, I want you to double check your work, align with this, and then move forward. If you did have this, well, good for you. Still move forward. Using what we found for w1 over w and w2 over w, u1 is the integral of w1 over w, and once we use integration by parts, we get negative 2/3 x e to the negative x over 2 minus 2e to the negative x over 2. Don't forget, y1 was e to the negative x over 2, which is going to be useful to remember because we're going to form u1, y1 for our particular solution. Continuing on with u2, after we integrate, collect like terms, again, integration by parts, we have negative 1/3 x e to the x. By the way, for the integration by parts, some people do funky things here. What I would recommend is s is equal to x plus 1, and then t is equal to, well, I guess it would be dt is e to the x dx. Some people would distribute and like do things separately. I just don't recommend that. You got a product here, pull one to be s and one to be dt. Now multiplying u1 by y1 divides out the e to the x over 2, and we end up with negative 2/3 x minus 2. Multiplying u2 by y2 divides out the e to the x effectively and gives us 1/3 x. We have like terms, and so yp finally is negative x minus 2. Y, which is yc plus yp, is going to be c1 e to the x over 2 plus c2 e to the negative x minus 2. We have to do all of that before we apply the initial conditions of y of 0 equals 1 and y prime of 0 equals 0, because the input function or the forcing function was built into the initial conditions, and so the particular solution needs to be there before we can incorporate the initial conditions. If y of 0 is equal to 1, then c1 plus c2 minus 2 is equal to 1. Then you can confirm that 1/2 c1 minus c2 minus 1 is equal to 0. Solving that system of equations is going to give us y is equal to 8/3 e to the x over 2 plus 1/3 e to the negative x minus 2. Next up, we have something that's a little bit more challenging. Our differential equation is y double prime minus 4y equals e to the 2x over x. Now, this is not a type that we can do using a different technique. This is all that we got here. What I'd like you to do is, as much work as you can, get to where you have u1 prime and u2 prime, and then come back and we'll take it from there. Our auxiliary equation has roots m equals plus or minus 2, giving us functions y1 equals e to the 2x and y2 equals e to the negative 2x as our fundamental set of solutions. The Wronskian w, once all is said and done, turns out to be negative 4. w1 turns out to be negative 1 over x, so u1 prime, which is w1 over w, is 1 over 4x. That's nicely behaved. w2, when all is said and done, is e to the 4x over x, giving u2 prime as negative e to the 4x over 4x. Now I wanted you to come back at this point, because while we can find u1 by integrating, we can't by integrating find u2. u1, though, is 1 over 4x dx, and so this is 1/4 times the natural log of the absolute value of x. Absolute value, I'm going to say, is like optional, just because our input function e to the 2x over x excludes x equals 0. And so our solutions are only valid when x is always positive or when x is always negative. You could make an argument, I'm assuming that x is positive, and so dropping the absolute value. u2 is the integral of negative e to the 4x over 4x dx. We do not have an antiderivative for this. We can't write down a closed form solution for this. What we then do is we turn this into a definite integral with the lower limit x naught. If we had an initial condition number, like an input, y of 3 equals 5, we'd put 3 down there. But we don't have that, so we're just going to say x naught, some constant. Upper limit is x. And then the integrand is going to use the dummy variable t. So u2 is equal to the integral from x naught to x of negative e to the 4t over 4t dt. That's what we're going to use. Y is then c1 e to the 2x plus c2 e to the negative 2x plus. Now remember, in yp, we have u1, y1. So we have 1/4 e to the 2x times the natural log of the absolute value of x minus, because this integral has a minus in it, u2, y2. And so e to the negative 2x times the integral from x naught to x of 4t, e to the 4t over 4t dt. And as uncomfortable as that looks, that's our solution.